Our first vocabulary word today is expression. An expression is a mathematical statement but it's only a mathematical statement, so it does not have any equal signs. So an expression is just a bunch of terms put together, a mathematical statement. An equation is super similar to an expression because an equation is a mathematical statement but it's a mathematical statement of equality, saying one thing is equal to the other, so we will have equal signs. That makes an equation. They look very similar. People get them confused a lot. So if you see an equal sign, that means it's an expression. It's an equation because you see the equal sign. If you see no equal sign, it's just a mathematical expression. We're talking about like terms. You probably used this phrase last year. Does anyone remember what like terms are? They're parts of an expression that what? What do they have in common? No takers. They have the same variable and exponent, which we will define in a second if you don't know what those are. So like terms, we're looking for parts of an expression that have the same exact variable and the same exact exponent. We want to be able to identify these like terms, things with the same variable and exponent, because we want to be able to combine like terms. Now, I told you last class that mathematicians are lazy, and I'm a mathematician at heart, so I'm going to use the acronym CLT from here on out for combine like terms. Is that okay? You can also write down CLT when I'm asking you what you're doing, so you don't have to write all that out. But when I'm talking about combining like terms, I'm looking at trying to find the like terms, find them in an expression, and add them together. So add our like terms. That's what we're talking about when we're going to CLT. Let's just add all the things that are alike together. So a solution of an equation, we were finding these last time. They're when we found like x equals some number. And what we did when we found that is we plugged it back in. Does anyone remember what we were looking for when we plugged the number back into the equation? When we were checking our work? Yeah. We put a little check mark next to it. See if it matches. We're looking to see if it's a true mathematical statement, right? So we were looking to see if our solution is a value that makes that equation true. And we got excited when we had a true mathematical statement at the end. We put a little check mark next to it because we found a value that made that equation true. That was our solution. Might have just called this the answer last year. That's fine, but this year you're going to call it a solution. We've already talked about inverse operations today, but inverse operations are mathematical operations: add, subtract, multiply, divide, square, square root, operations that undo each other. Add undoes subtraction, multiplying undoes division, on and on. Those are inverse operations. They undo each other. Now, opposite terms and zero pair, I won't use all that much in this class, but it comes in handy in Algebra 2 and for one particular lesson in the third 6 weeks here. Opposite terms or a zero pair are things that combine to zero. So if I was asking you, what would combine with 2x to make 0? What's its opposite term?
Negative 2.
Negative 2x. Yeah, there you go. That's its zero pair or its opposite term. Because if I combine them together, I'd get 0. So if I gave you negative 7y, what would be its opposite term? Positive 7y. Very good. Those are zero pairs or opposite terms. Now the next three letters, the next three vocabulary words here are super important. These are all vocabulary words describing pieces of what we're going to call a term. Every term in mathematics has these three pieces, whether or not you see them. Here's an example of a term. How about 5x squared? That one has all three pieces showing. Let's talk about the easy one first. What part of 5x squared is the variable? The x, the letter, right? The variable is the letter. So when I look at 5x squared, I know that the letter, whoa, can't read my handwriting. I know that the letter is my variable. It's my unknown. Could be an x, could be a y, could be a z. The coefficient is the big number in front of that variable. So in this case, what's my coefficient? The 5. That tells me how many times that x is multiplied. It's a scalar multiple. So I'm multiplying 5 times x. Which means that the only piece left we haven't talked about is the exponent. That exponent is the small floating number floating up there in the superscript. The small floating number tells me how many times x is multiplied by itself. We're going to talk more about exponents in the second semester, but we need to know that they're a part of every term. So we have a coefficient, the big number, the variable is the letter, and the exponent is the little floating number. Now, the last thing you probably did in 8th grade was start talking about the distributive property. I know you've heard of it before. I just want to clear some things up. The distributive property is the following mathematical property. We're going to say that if there's a number in front of some parentheses, does anyone remember what we do with that number in front of parentheses? Multiply, absolutely. I multiply it by both things inside that parentheses. So this would be a times b and a times c. You get to laugh at my art skills here in a second. So let's say that we're going to represent this by the a being a waiter. Here's the waiter. Okay, that's the tray that the waiter's holding, in case you can't tell. That's what it's supposed to be, at least. And we're going to pretend that the parentheses right here is you and your family or you and your friends sitting at a table. I'll do my best. Here's one person sitting at a table. Oh, they need another leg. Here's another person sitting at the table. Here's the other person sitting at the table. Awesome. So this waiter is in charge of the table. Okay, that's why it's in front of it. So if that waiter comes and brings 2 glasses of water to that table, is that enough water for everybody sitting at that table? No. It's not really fair unless the waiter brings water to everybody at the table, right? I'd be so angry if everybody else at the table got their water and I'm just sitting there thirsty. So we have to remember that when we have a waiter sitting in front of this table, we have to multiply it to every piece inside of it. So there may be 2 pieces inside this parentheses, or there may be 80. If there are 2 pieces inside that parentheses, how many times are you going to multiply? Twice. A times b, a times c. If there are 80 terms inside this parentheses, how many times are you going to have to multiply? 80 times. I won't make you multiply things 80 times, don't worry. We'll do 2, maybe 3 things whenever we're distributing. So you've got to make sure, it's a pretty common mistake just to do this and forget about the other part. Make sure you have enough arrows telling you that waiter visiting everybody sitting at that table. Awesome, great, hooray. We have now all of the vocabulary we're going to be using for probably the rest of the day and for a significant amount of time in this class. If you open up your notes brochure, on the inside are all the practice problems we're going to do today. Some of them I'm going to do with you. Some of them I'm going to ask for you to do on your own. Ask questions when you got them. Try them. The first kinds of questions we're going to be working on are simplifying expressions. Now, it says at the top combining like terms. But when I'm combining like terms, all I'm really doing is simplifying. And we defined combining like terms as adding together the pieces that have the same variable and exponent. So if I look at number 1, what 2 pieces there have the same variable and exponent? The 4m and the 3m, absolutely. I like to identify these by just kind of underlining them. Not like a division sign, but just underlining them. So I know that those are like terms. All I have to do is add them together. So what is 4 plus negative 3? 4 plus negative 3. 1, I see you. That's a 1m, right? There's only 1m left. Now what do I do with that 5? It's all the way by itself. It has nothing to combine with. Do I just let it fly away?
No.
No, you got to add it towards the end. Now this is a sufficiently fine answer, but I'm going to ask that you get used to not writing this M here, or this 1 in front of the M, because your online homework website actually would count this wrong, and it would count this correct. Though I know they are both correct, we need to get into the habits of not writing our 1s in our final answer. If you need the 1 to be there while you're working the problem so you remember what the coefficient is, that's totally fine with me. But at the very, very end, try to not write your 1 there anymore. It's better math habit. Awesome. Now here's a note I want to make sure we have, because when we get more complicated questions, you might run into this. When we added the m's together, did we change the letter? No. Did we change the exponent at all? No. So the only thing we're going to do when we're CLTing is only change the coefficient. Only change the coefficient when we're doing this, which is the big number. You don't change the letter, you don't change the exponent. Only change the coefficient. That will make sure you're combining them together the way you need to. We look at number 2. What is like with negative 2x? 6x, absolutely. All I have to do is add those things together and not change the letter or the exponent. What is negative 2 plus 6? 4, so I have 4 x's. But now do you notice that 2 and negative 1 are just good old-fashioned numbers? Those are also like terms. They technically have the same letter and exponent. They're both invisible. Okay, they have no letter and they have no exponent showing. But I can combine them together since they're good old-fashioned numbers. What's 2 plus negative 1? 1. And there we have our simplified version, our combined like terms version of that expression. Okay, I'm actually going to skip down to number 4. So make sure you're looking at number 4 for this next one. This is a complicated expression here. It says 3g squared minus 4 plus 8 plus 5g plus g squared. Wow, I had to take a breath in the middle of that. There's so many things happening. So let's start making it simpler by combining our like terms. What is like with the 3g squared?
You combine all the g.
Ooh, see, remember, I'm glad you said that because it's a point I want to make. Remember we said like terms have to have the same variable and exponent. So does this have the same exponent as g squared? No, so this is totally something I might do myself. So I got to remember that I'm looking just for the same variable and exponent. So I can combine 3g squared and g squared because they have the same letter and exponent. When I combine those together, what do I get? I heard it. 4g squared. How did you get 4 though? I only see a 3 and then I don't see another number. There's an invisible 1. The coefficient of 1 we don't have to write. Like I said, it's good math habit not to write it. But if you need to write it down so you can see it and remember 3 plus 1 is 4, that's fine. Now I'm looking at my g's. Is there anything I can combine with 5g? No, it's the only term up there that only has a g. So we're going to let it float down and add it. Now what about these good old-fashioned numbers here? What can I do with them? I add those together. Good old-fashioned numbers I can combine. Negative 4 plus 8. Positive 4. And we have our combined like terms, our simplified expression. Let's do a check to make sure we know what we're doing. Number 3 is for you. Go ahead and try number 3 on your own. I'll give you about a minute to try to combine your like terms together. All right, so I'm seeing really good things. Here's what I'm seeing on a lot of people's papers. A lot of you said, all right, cool. We're going to combine like terms, which means I got to look for the same letter and exponent. Well, here's 4x squareds, and here is another term with an x squared on it. 4 plus 5 is 9x squared terms. Then we looked and we saw that the negative 3x has nothing else it can combine with, so I still have to include it in my answer. It's part of the expression. And then I have a good old-fashioned number that can't combine with anything either. So I put a plus 1 at the end. How did we do? It looks good around the room. Awesome. Here's the first skill I'm going to quiz you on next time. So if we can do this, simplify expressions, we're going to get 100 on part of our quiz. Woo! Awesome. Let's kick it up a notch. So we're going to be looking now at equations, which is what we solved last time, that use the distributive property. So we're going to not just be doing one single step to get to our solution. We're going to have to do some multi-step things. Potentially multiplying, distributing the number in front of parentheses, like 8 times x, which would be 8x, and 8 times 3, which would be 24. We're going to be using that distributive property to make sure we have the waiter visit every person or term at the table or in the parentheses. Then we will continue using our inverse operations, which we learned about last time, to solve our equations. What is it? I was going to say number 1, but really it's number 5. We'll do the first 2 together, and then I'm going to let you try on the other ones. But number 5, we have -3, parentheses 2r plus 7, close parentheses, equal to 3. And we want to solve this. I would follow about the same steps as I did last time, just kind of repeating and repeating and repeating the steps until I get down to a solution. Now we notice this -3 is in front of parentheses, so what's that vocabulary word we're going to do? What's that called? We are going to multiply. What's the word for it? Starts with a D? Distribute. Yeah, we are multiplying, so I'm glad you knew that. We are going to multiply -3 times 2r and -3 times positive 7. -3 times 2r would be a -6r, and -3 times positive 7 would be a -21. So my first step on all of this is to distribute, and that's all I have to do. I just rewrite the equation, having gotten rid of all of my distribution problems, so that I have no more parentheses left. I distribute. Then I start using my inverse operations. We know we want to get all of the letters onto the right side and all of the numbers onto the left. Wow, that's the left. All of the letters onto the left side and all of the numbers onto the right side. We start using our inverse operations. I'll drag the 21 over here, and what does it change to when I move it over there? Positive 21. So then I'd have a -6r equal to 3 plus 21, which is 24. Awesome. I used inverse operations to move things around so that I had all of the letters on one side and all of the numbers on the other. Now, -6 and r are currently multiplied because they're smushed next to each other. How do I get that -6 to disappear? I divide, thank you. Yeah, we divide by -6 on both sides so that the r is left by itself, and r would be equal to whatever 24 divided by -6 is, which is -4. So I used inverse operations actually twice to reach the solution of this equation. So it's what we did last time, just like doubled up. They're just a little bit longer of problems, going those steps over and over again until we arrive at a solution. Now we're good students, so we're going to check our work. This is the only one we're going to check our work together on our notes, but I know that you're going to check all of your work on your quizzes to guarantee you get it right. Now last time we said we check our work by doing what with this solution? Yeah, put the number back in the problem, you substitute it back in, which we will end up being multiplying, because we want to see if -3 times 2 minus 4, or times -4, plus 7, we're hoping that's equal to 3. Now the nice thing is you now have a calculator on your desk. Will someone type all of this into their calculator for us? Because if you press enter and get 3, we just got this question correct. Thank you, those of you who grabbed your calculator. Woot woot. Yes, all the parentheses matter. Did we get it, Bree? Yeah, so when she pressed enter, she got a 3, so we get the mathematical equation 3 equals 3. That's a solution because it's a value that makes my equation true. That's the only one we're going to check on these notes, but guarantee yourself you get it right. It takes 30 seconds to plug it in a calculator and check that you get it all the way correct. We're going to try number 6. Same steps. We notice that we have a number in front of our parentheses, which means what are we going to do with it? What's that called? Yeah, distribute. We're going to distribute the -4, which is multiplying. -4 times 2n, absolutely -8n. -4 times -5. Negative times negative is a positive 20. Very good. So I've done my distribution step. I need to start moving things around so I have my x or my n isolated. I'll take the 20 and I'll move it to the other side. What happens when I move it? -20, very good. So now I have -8n, because I did nothing with that part. It gets to just float down to the next line. -28 minus 20. If the signs are both the same, add the numbers now. Keep the sign that goes with them. That's the way, the how. -48. What's the last inverse operation I'm going to do here? Absolutely. Now I'm going to do this wrong for a second. I want you to tell me what I did wrong because I see this mistake a lot and I want us to stop doing that now. What do you notice that I did that I didn't do last time? I put the n down there. So guys, a lot of you will do this and it doesn't mess you up in Algebra 1 because you know you're just dividing by -8. But in Algebra 2, you will actually do some equations where the variable is in the denominator. Totally different monster. We're not there yet. So if that's your habit to put that n there, I didn't see it in this class, but I've seen it in some of my other classes. Please, please, please try your best. I don't know how to erase this now. To not put the n. You're only dividing by -8, not -8n. Okay, so we divide and we end up with n left on the other side. And -48 divided by -8. Negative divided by negative is a +6. Yeah. Awesome. Now we have our solution. If we were concerned we got it wrong, which we should be, because we're good students, we don't want to check our work, we plug that number back in to see if it makes the equation true. Thus making it our solution. Yes. So we're trying number 7. And we'll get to number 8 in a second. Oh, I do not know what's happening. For number 7, we start off by trying to figure out what we need to uncover. The x is inside some parentheses, so we know that we have to use distribution to get rid of the parentheses. Numbers in front of parentheses, we multiply inside 9 times x, 9x, thank you. And 9 times 2, 18. Awesome. And we get here, we've done our distribution step. Now we start using inverse operations to get the x isolated. I know this 18 needs to go over here because it doesn't have a letter on it. So when I move it over there, it's going to be -18. If the signs are both the same, add the numbers now. Keep the sign that goes with them. That's the way to how. Cool, we've done one set of inverse operations, always wanting to do adding and subtracting before we do multiplying and dividing. Now we're on our multiplying and dividing inverse operation, so we're going to divide by the number in front of the x, the coefficient. We divide by the coefficient, we'd get 27, or -27 divided by 9. Our solution is -3. Questions, comments, concerns? Let's super prove it to ourselves that we know it. We've got number 8. If you have a question, flag one of us down. Try number 8. Number 8, I would notice right away that the x's are on the side that I don't like them to be on. So a total option you can take, not necessary, but I like to do this, is when I draw my line, I'm just going to go ahead and flip-flop the sides so that I have the x on the side that I enjoy it being there. I'm just going to go ahead and change it exactly how it looks. Oh, that makes me feel much better. That's an optional step. You don't have to do that. You can totally solve this with the x's being on the right instead of the left, but this is just my personal preference to do this. Now it looks like all the rest of them, so I know that this number in front of parentheses, I'm going to have to distribute, which would be 2 times 4, 8. 2 times x, 2x, equal to 4. Whichever way you're moving numbers, it should be to where your good old-fashioned numbers are all going to the side away from the x. I'm going to move the 8, therefore it becomes -8. And I'd end up with 2x equal to 4 minus 8. Different signs are different rules. Now you must subtract. 8 minus 4 is 4. Keep the sign of the bigger one. Now you know the facts. Last set of inverse operations to do to finish this problem out is to divide by 2 on both sides. -4 divided by 2 is -2. If we were unsure if we got this right, what could we do to check our work? What could we do with this solution to make sure we get it right? Yeah, we could plug it back in into the very original equation, throw it in a calculator, and make sure it gives me a true mathematical statement. All right, last one we're going to do together, but before we get started on this problem, which probably is my favorite problem on the notes, because we're going to write out in words what happens on each step, so that when you look back at your notes, this might be the one that helps you out the most. Before we do that, though, I do need you to put a big old scratch mark through the second line. We don't actually use this step when we solve because we are smarter than this line. We don't need the work step that goes here. We've always skipped it, so we're not even going to look at that one. I'm going to label these steps 1, 2, 3, 4, and 5, just so you know what I'm talking about when we go through it. Without saying it out loud, because I want you to think, look at the step 1 to step 2. Don't say it out loud. What's the name of the step that happened from step 1 to step 2? Think, don't say it. Keep it in your brain. I'm giving people some time to think. I know you know it.
Oh,
Hold on. Okay, raise your hand if you think you know what that's called. What is it called? Absolutely, this is called distribution. Did you notice that we had a -2 in front of a set of parentheses? It wasn't at the front or at the back. It was there in the middle of the equation. And we took that -2 and we multiplied it times both pieces inside that parentheses and ended up with -2x. -2 times -10 is +20. We use distribution. We let that waiter visit everybody in that table. Look at number 2 and 3. Don't say it out loud. Can anyone figure out what happened between step 2 and 3? So in number 2, we had 3 terms on the left side, and in number 3, we only have 2 terms in the left side. What did they do? They simplified. What's the vocabulary we use for simplified today? 3 letters?
CTL.
CLT. Yeah, combine like terms. Thank you. Yeah. We simplified this down. We combined our like terms. Our like terms were the 7 and the 20. Those are good old-fashioned numbers. I can combine those together. I can make it simpler. That makes my life a lot easier. So if you notice that happens, you can always CLT. Combine your like terms. Look, but don't say it. What did they do from line 3 to line 4? In line 3, we had a 27 on the right side, left side. Wow. On number 4, the 27 disappears, but also this 15 has changed. Who can tell me what they did there? Inverse operation. Which inverse operation did they do? They did subtraction. They wanted to move the 27 to keep the x term all by itself, so they used subtraction to move it to the other side. Great eye. Last step. What's the name that they did in the last step from 4 to 5?
It's just
Inverse operations again, and what inverse operation did they use this time since we got our x by itself? Division. So when we're solving, we're going to look to move things with adding and subtracting inverse operations before we use our multiplying and dividing inverse operations. When we got to this last piece, what's the new vocabulary word that you're going to call this? You're not going to say it's the answer. You're going to say it's the... Absolutely, the solution. Thank you. Woohoo! That's our solution. X equals 6.